In this video, we are going to be talking about how we can find the median, quartiles, and other percentiles. Now, the median is the value that is 50% of the way through the distribution, and it splits the area under the curve y is equal to f of x into two halves. In the Stats 2 course for A-level maths, you learned that if m is the median, then for f of x, defined for the range of values of x from a to b, the integral from the lower limit a up to m of our function f of x with respect to x should be equal to 0.5. Now, this is the same as the probability that x is less than or equal to m, where m is the median, and that's equal to the cumulative f of m, which is equal to 0.5. In other words, up to m, we would have accumulated a sum total of probabilities equal to 0.5. So this is very important. Now we can also talk of the quartiles and other percentiles. The lower quartile, Q1, is a value that is 25% of the way through the distribution. And so we know that if we integrate from the lower limit a up to Q1, the lower quartile, the function f of x with respect to x, we get 0.25. So using the cumulative function, that's the same as f of Q1, and that's equal to 0.25. Then the upper quartile is a value that is 75% of the way through the distribution, which can be found by integrating from the lower limit a up to Q3, which is the upper quartile value, the function f of x with respect to x, and that equals 0.75. But this is the same as the cumulative function f of Q3, and that's equal to 0.75. So in general, for all the percentiles, the cumulative function f of the nth percentile is equal to n over 100. So now we want to take a look at a question from a past paper which involves finding the median and see how we can handle it. Here's the question. If you'd want to attempt it before checking out my solution, then you can do so. Now the question says the continuous random variable x has probability density function f given by f of x is equal to a fifth of x for values of x ranging between 0 and 2, 2 over 15 of 5 minus x for values of x between 2 and 5, and 0 otherwise. So in A, find the cumulative function of x. Alright, so for the cumulative function of x, we are going to start by the first piece here, where we integrate from 0 to some value t, the function f of x, which is a fifth of x, with respect to x. If we do that, we are going to get 1 over 10 of x squared, with the limits 0 to t. And if we substitute t here, we get 1 over 10 t squared, and it's minus 0, substituting 0 there. Which therefore means that the cumulative function for the range 0 to 2 will be f of x is equal to 1 over 10 x squared. And that's for the range of values between 0 and 2. Now we want to look for the cumulative function for the range 2 to 5. So for that, we will start with the first piece. So that's the integral from 0 to 2 of a fifth of x with respect to x, and it's plus the integral from 2 to a value t in the second piece of 2 over 15 of 5 minus x, and it's with respect to x. So here we get a tenth of x squared for the limits 0 to 2, and it's plus factoring out 2 over 15, and integrating 5, we get 5x, and it's minus integrating x, that's x squared over 2, and that's from 2 up to t, like this. So here, if we substitute 2, we get 2 squared over 10, which is 4 over 10, which is 2/5. So it's 2/5 plus, substituting t here, we already have the 2 over 15. And substituting t, we get 5t minus t squared over 2. And substituting 2, we get 2 times 5, that's 10. And it's minus 2 squared over 4, which is 2. So it's plus 2. So it's going to be like this. So we are going to be having 2/5, and it's plus 2 over 15 times 5t. We get 2/3 of t from that. And it's minus 2 over 15 times t squared over 2. That gives us t squared over 15. And here that's minus 10 plus 2, which is minus 8. And 2 over 15 times minus 8 gives us minus 16 over 15. So that's what we'll be having here. And we can simplify it and rearrange. So we start with minus t squared over 15. And we have the 2/3 of t. And we have the 2/5 minus 16 over 15. And that gives us minus 2/3. So minus 2/3 here. And we can actually factor out 1 over 15 just to simplify it. And inside the bracket, we'll be having t squared minus 10t plus 10. So this is what we have. So therefore, we are saying the cumulative function f of x is equal to minus 1 over 15 of x squared minus 10x plus 10, and that's for the range of values here between 2 and 5. So that's 4, 2 to 5. So that's how we do it. So we can write down the cumulative function all at once. So we are saying here f of x is equal to, and we have for the first piece of our CDF, that's 1/10 of x squared for values of x between 0 and 2. So I'm going to write 1/10 of x squared, and that's for 0 to 2. And we've gotten that it's also equal to minus 1 over 15 of x squared minus 10x plus 10. And that's for 2 to 5. So that's from 2 to 5. We know that it's 0 for values of x less than 0, and it's 1 for values of x that are greater than 5. So this is the CDF. So that's it for this first question A. Let's go on to part B. On B, the question says, find the median value of x. All right, so now for the median value of x, we can use the cumulative function. And we know that for the median value, f of m should be equal to a half. All right, so if we look at the cumulative function that we got right here, between 0 and 2, we know that we do not get enough accumulation of probabilities to reach 0.5 because we got that to be 2/5. So we know that m lies within the range 2 to 5. So we're going to use this second function, second piece here. So we'll be saying f of m will be equal to minus 1 over 15 of m squared minus 10m plus 10, and that's equal to a half. All right, so we simplify this. And so here I'll multiply both sides by 30. So both sides by 30. And if I do that, on the left side, 15 into 30 is 2. So we'll be having minus 2 of m squared minus 10m plus 10. And it's equal to 2 into 30. That's 15. So that'll be minus 2m squared plus 20m minus 20 equal to 15. That's equal to minus 2m squared plus 20m, and minus 20 minus 15 is minus 35, and that's equal to 0. So eventually, dividing both sides by minus 1, we get 2m squared minus 20m plus 35 equal to 0. So we can now solve for m. Now solving for m, you can use the quadratic formula, but here for convenience, I'll use the calculator. So I'll go to equation 5 and option quadratic 3, then 2 for A, minus 20 for B, and 35 for C. So the values we get will be 7.74. So we have 7.74, and we also have 2.26. So 2.26. So the answer we're looking for here, which is within range, is m is equal to 2.26. So that is what we get for the median. Let's go on to the last part. On part C, the question says, find the probability that x lies between 1 and 3. Alright, so for probability that x lies between 1 and 3, we say that's the same as f of 3 minus f of 1. Now, when we talk of f of 3, 3 is within the second piece of our cumulative distribution function. So we get that by substituting 3 there. So that's minus 1 over 15 of, and that's 3 squared, minus 10 of 3, and it's plus 10. And it's minus f of 1. 1 lies within the first piece. So that'll be minus of 1 over 10 of 1 squared. So we'll be having here minus 1 over 15 of, this is 9 minus 30 plus 10, which is minus 11. And that's minus 1 over 10. So basically we have 11 over 15 minus 1 over 10, and that simplifies to 19 over 30. So that's the answer here to part C. So that's it for this question here.